Good morning everyone. Welcome to another session of factor and multiples. Today we will find how to find the HCF. We have basically three methods to find the HCF. HCF full form is highest common factor. Okay, so how will you find the HCF, highest common factor? So basically we have three methods in this. One method is to finding the common factor method, second one is prime factorization method, and third one is division method. Okay, so first I will discuss the common method. Common factor method means suppose you have three numbers 92, 108 and 124. If you have these three numbers 92, 108 and 124, first you have to find the factors. Factors means which table this particular number is divisible. So that table will consider as your factors. Suppose I have 92. First I will check with 92 divisible by 1 gives me 92. 92 divisible by 2, when you divide by 2 gives you quotient 46. When 92 divided by 4 gives 23. 92 divided by 23 gives me 4. And after that, because at this point when there is no single number left, you can divide by whatever you get the quotient in the previous number, consider as your divisibility. Now like 22 divided by 23, 4. 92 divided by 46 give you 2, and 92 divided by 92 gives you 1. Okay, so in this case we got the factor of this 1, 2, 4, 28, 23, 46, 92. Similarly, factors of 108. 108 divisible by 1, 2, 3, 4, 9, 12, 27, 36 and 54. Divisibility means when you divide you get the quotient only and remainder will be 0. So these are my factors 1, 2, 3, 4, 9, 12, 27, 36, 54, 108. Similarly, I check with 124. Factors of 124 divisible by 1, 2, 4, 31, 62, 124. So these are the factors. So I just pick these factors right under this. Now you look at the factors of all these three numbers 92, 108 and next is 124. Now you have to check what is the highest number common in this. When I found that highest common number is 4, so I mark that one 4, so that 4 will be my HCF. Now next is prime factorization method. In prime factorization method, what you have to do, basically you have to check with the divisibility of the prime numbers. Divisibility of prime number means your prime number starting from 2, okay, 2, 3, next prime number is 5, 7, then 11, 13 and so on. One by one you have to check the divisibility and move further, but you have very first you have to starting from 2, because 2 is the lowest prime number. When number is not divisible by 2, then you have to move to the next prime number. If I have like 198 and 296, first I will find the prime factorization of each number. Like 198 when divided by 2 gives me 99, when divided by 3 gives me 33, when divided by 3 gives me 11. Then 11 is again as a prime number, so 11 ones are 11. So prime factors of 198 is 2, 3, 3, 11. Similarly 296. Now you check the divisibility with the 2. If it not goes on to check for the next 3, then next prime number 5, next 7, next 11, then so on. Like 2, 1s are 2, 2 4s are 8, 2 8s are 16. When you divide 296 by 2 gives you quotient 48. Similarly, 148 divided by 2 gives you 74, and 74 divided by 2 gives you 37, and 37 at last is again a prime number. So in this way you have to write the prime factors. Like 198 is 2 3 3 11, 296 is 2 2 2 37. So here you have to find only common number that will be available in both the prime factors. Like here 2 and 2, because here is single 2 and single 2 is there. Here is also 2, but next 2 is not there and next number is not there. So you have to only circle this 2 because that is common between the two factors. Then 2 is considered as HCF of these two numbers. Now my third method is division method. Suppose I have a question 204 and 316, that is your exercise 2.2 third question B part. How you find the HCF? So what will you do? You will keep bigger number inside and a smaller number outside, consider as divisor, and 316 consider as your dividend. Now 204, when you first multiply by 1 gives you 204. After subtraction give me 112. Now 204, we need the number less than 204. Previous divisor become the dividend for the next, and remainder will become the divisor. 112, ones are 112. When after subtraction give me 92. 92 remainder now changes to divisor, and last divisor changes to dividend. 112, 92 ones are 92. After subtraction give me 20, and 24s are 80. After subtraction 12, 20 become again dividend, 12 become divisor, 12 ones are 12. After subtraction I get 8, and 8 ones are 8. After subtraction 4, 4 twos are 8. So whatever number at last here I got, after division I get the remainder 0, so that number is considered as my HCF. Then HCF of 204 and 316 is equal to 4. Now I have your some statement questions. Your fourth question is, find the greatest number which divided 147, 296 and 365, leaving remainders 14, 11 and 4 respectively. In this question you have to find the greatest number which divided by these three numbers and leaves the remainder 14, 11, 4 respectively. If 14 is divided by a particular number, leaves the remainder 14, that means what will be the exact number when you subtract 14 from 147, 11 from 296 and 4 from 365? That will be your exact number. Now you have to find the exact LCF of these three numbers. So here it means when 147, because we don't know the number, that we have to find. When 47 divided by a number leaves remainder 4. Leaves remainder 4. That means my exact number will be exact. So exact number will be 147 minus remainder is 14. Here remainder mark is 14. So my exact number is 147 minus 14 gives me 133. Similarly 296 minus 11 gives me 285. Now 365 minus 4, similarly other number. Similarly 296 minus 11 give me 285. 365 minus 4 gives me 361. So that means when, because according to your question, when 296 divided by a number, it leaves the remainder 11. So exact number will be after subtraction will be 285. Similarly, 365 after subtraction 4 gives me 361. Now you have to find the HCF of these three exact numbers, that is 133, 285 and 361. Mostly this word type of problem we use long division method for finding the HCF. So what I will do, first I will pick these two numbers, bigger number inside consider as dividend and smaller number outside consider as divisor. First it goes on 2, that give me 266. After subtraction give me 19. Now 19 become the divisor and 133 last divisor become the dividend. Now it 19 sevens are 133. So that means here my remainder is 0. Now if I got the remainder 0, a particular divisor, so this divisor is considered as your HCF, but still I have a third number. Now I check whether if this is the divisor of another number, as a result gives you remainder 0, that means 19 is the HCF of these three numbers. Now when you check with the 19 with the third number, 19 ones are 19, after subtraction give me 17, 1 is carried downward, so that means minus 171 multiplied by 19 multiplied by 9 gives me 171. So here I got the remainder 0. So that means 19 is the HCF of 133, 285 and 361. So greatest number which divides 147, 296, 365 leaves a remainder 14, 11 and 4 is 19. So greatest number which divides 147, 296 and 365 leaves remainder 14, 11 and 4 is equal to 19. So that is the exact answer. Now my next fifth question is of your worksheet of your exercise 2.2. You have to find the greatest possible length which can be used to measure the length 7 meter, 3 meter 85 centimeter, 12 meter 95 centimeter exactly. It means if there is a condition of to find the greatest number, always you go with the HCF, means highest common factor. But condition is that I have three numbers, I have to find the greatest possible number. Ultimately if I have three numbers, so greatest possible number is finding the HCF of three numbers. But my problem is that in this question units are not same. One is in meter, one is in meter centimeter and another one is also meter centimeter. First I have to convert before finding the HCF into the same unit, then I can further find the HCF of these three numbers. If I converted all these numbers into centimeter, that will be easier for me to find the HCF. So 1 meter is equal to 100 centimeter. So 7 meter means 700 centimeter. Then 3 meter 85 centimeter means this is already in centimeter. Only you have to convert this into 3 meter. That is 3 into 100 plus 85 is equal to 385 centimeter. Next one is 12 meter 95 centimeter gives you 12 into 100 plus 95 is equal to 1295 centimeter. Now you have to find the LCM because all three numbers is in the same unit. Now HCF of 700, 385 and 1295. Same thing, I will go with the long division method. First I pick these two numbers. Bigger number consider as dividend and smaller number is my divisor. First it goes on 1, gives me 385. 700 minus 385 give me 315. Now 385 divided by 315. First it goes on 1. After subtraction give me 70. Now 70 remainder becomes the divisor and last divisor becomes the dividend. Now it goes on 4 tables, give me 280. After subtraction this is 35 and 35 2s are 70. Here I got the remainder 0, but I have to check this HCF, which divisor gives me remainder 0, with this number 35 with the another number like 1295. Check with 35. First is goes on 3 table, 105. 35 3s are 105. After subtraction give me 245 and 35 7s are 245. Here I got the remainder 0. If I got the remainder 0 with 35 also, so 35 is the HCF of 700, 385 and 1295. So my HCF is equal to what I got, 35. So greatest possible length will be 35 centimeter because I converted all terms into centimeter. Then greatest possible length is equal to 35 centimeter that we required. Now your sixth question. Sixth question is that what will be the greatest number which divided 1657 and 2037 leaves remainder 6 and 5. Same thing. If by dividing particular number it leaves the remainder 6 and 5, so first we have to find the exact number by subtracting the remainder. So after subtracting the remainder 6 from 1657 I got 1651, and after subtraction 5 from 2037 I got 2032. HCF of 1651 and 2032. Now you have to find the HCF of these exact number by long division method. Bigger number will be your dividend and smaller number will be your divisor. First is goes on 1651. After subtraction give me 381 and 381 becomes the divisor. 1651 becomes the dividend. Now you multiply by 4, gives me 1524. So after subtraction you get 127 and 127 will be the divisor and 381 will be the dividend. Now it goes on 3. When it goes on 3 it gives me exact 381, remainder 0. That means 127 divisor gives me the remainder 0. So 127 is the HCF and greatest number required is 127. Now my last question of 2.2 exercise. Here in this your statement, two containers contain 150 liter and 185 liter of water respectively. You have two containers, two boxes. In first container you have 150 liter of water and second 185 liter of water. Find the measure of tank of the maximum capacity which can measure the water of either container and exact number of times. Actually it is same like a condition is that in this what you have two containers contain 150 liter and 185 liter of water, and find the maximum capacity which can be measured the water of either container exact number of times. Suppose I have these two containers. In first container that will be 150 liter, another container is 185 liter. So what is the maximum capacity you have to arrange in these containers? That means each container, both container has exact number of times quantity will be there water. Like here level will be same, because we no need to pour more water, we have to arrange these two quantities of water in the same level, so that will be considered as maximum capacity of the container which can make the level equal. So for that case we can find the maximum capacity of the tank required. So in this case we have to find what is the maximum capacity of the tank to make it equal container. So the measure of a tank of maximum capacity which can measure the water of either container and exact number of times. Exact number of times you have to find the capacity of the particular container which you can manage the quantity to fill in the water in the tank. With the same quantity of water you can fill in the tank. So here maximum capacity, basically you have to find what is the maximum capacity of the tank required, because you have 150 liter and 185 liter of water. So first you have to find the HCF of this. Like here if you have 185 is your maximum number and smaller number is 150 liter. So you find the HCF of this to find the maximum capacity. That is, after subtraction gives me 35, and 150 divided by 35, 35 fours are 140. After subtraction gives me 10, then 35, 10 threes are 30, 5 twos are 10. So here my remainder is 0. So that means if you have to find the HCF of 185 and 150, that gives you, which divisor gives you remainder 0, that is equal to 5. So the maximum capacity of tank required is equal to 5 liter. So I will explain you again this statement. What is in the statement? Two containers, like these are, suppose two containers are there. In this 150 liter of water and 185 liter of water. Okay, so find the measure of a tank of maximum capacity which can measure the water of either container and exact number of time. It means इसका मतलब है कि आपको एक टैंक अरेंज करना है, ओके, जिसमें ये सेम क्वांटिटी का ही पानी आपको उसमें से शिफ्ट करना है, कहीं और शिफ्ट करना है टैंक में. तो बेसिकली किस मैक्सिमम कैपेसिटी का आपको टैंक चाहिए होगा कि ताकि ये दोनों वाटर की इक्वल क्वांटिटी ही कहीं पर ट्रांसफ़र हो. बेसिकली हमने यही निकालना है इसमें, कौन सी इक्वल क्वांटिटी ट्रांसफ़र हो. तो जहाँ पे मैक्सिमम कैपेसिटी आ जाती है वहाँ पे हम निकालते हैं HCF. तो हमने जब दोनों का HCF अभी निकाला तो मेरे पास आ गया मैक्सिमम कैपेसिटी ऑफ टैंक रिक्वायर्ड इज़ 5 लीटर की. मुझे मैक्सिमम 5 लीटर कैपेसिटी का टैंक चाहिए, मतलब हर एक टैंक 5 लीटर का ही होना चाहिए. ऑब्वियसली आप इतना सारा पानी तो कहीं पर लेके नहीं जाओगे. बड़ी बड़ी जो आपके गाड़ियों में टैंक्स होते हैं वाटर के, किसी में 150 लीटर कोई गाड़ी का कंटेनर होता है, किसी का 185 लीटर ऑफ वाटर होता है. ये तो बहुत ज़्यादा होता है. अब इसको कहीं पर शिफ्ट करना है, आपको कहीं पर ट्रांसफ़र करना है, तो आपको कितना मैक्सिमम कैपेसिटी का छोटा सा टैंक चाहिए. जिससे कि इक्वल क्वांटिटी में वो ट्रांसफ़र हो सके। तो उसके लिए हमने HCF निकाला। तो कितनी मैक्सिमम कैपेसिटी का मुझे टैंक चाहिए, दैट इज़ 5 लीटर। थैंक यू, हैव अ नाइस डे।